Today we'll be solving this problem, unique parts 3. It's a LeetCode hard problem. So what does the problem state? The problem states that you are given an m cross n integer array grid where grid of ij could be 1, 2, 0 and minus 1. 1 means the starting square, 2 means ending square, 0 is empty where you can walk over, and minus 1 is an obstacle. Okay. So this is a fancy robot kind of thing. These are all the empty ones. I need to figure out the number of ways, right? It can walk 4 directionals. Okay. So one way would be this, this, this and this. Other would be this. Hmm. So once you walk over a path, you cannot again walk over it. So one path would be this, one path would be this. When it comes here, okay, let me draw it. Yeah, so the question is like, you're given this kind of grid. What was the size? It was a 3 cross 4, right? So I'll make a 3 cross 4 grid. Yeah. Yeah. So let's keep it like this. Or else let me redraw it once again. It was a 3 cross 4, right? So 1, 2, 3 and 4. Yeah. This is your starting point. This is your ending point. Let me draw it with a different color. This was your ending point. And this was an obstacle, right? You couldn't walk from here. So the question basically says, you can visit this, this, and get a path from here. Or else you can go this way and reach here. So these are the two ways. So why cannot you go like this? And once you visit this one, you cannot actually visit this one because you have previously visited this. That's what the problem says. Every non-obstacle square exactly once. So you cannot visit one square more than once. If you visit and go this way in this path, it would be considered invalid since you are visiting this square twice as well as this square too. Okay, so this path is invalid. That's what the problem says. So to think of any such grid problems, one easy way would be graph traversals, right? Graph traversals in the DFS or BFS. In this case, I would prefer DFS because you need to explore all paths. It's a bit snappy to write the logic with DFS. Whereas BFS it's more likely to use when you're asked some shortest path or something. So to start with the problem, however, obstacles are unvisitable, like you cannot visit them. So how about marking the grid with obstacles once you visit them so that you cannot visit them again, right? If I have visited this, I would mark this as an obstacle so that I cannot go back. Similarly for this, once I reach here, I'll mark it as unvisitable, like an obstacle, and same for this. And at last, I would reach this thing. Then I cannot go here. Uh, Only way left is this one. I would mark this as obstacle. I can go this way or I can go this way, whichever is good. You can go. If I choose to go this way, I'll mark it as obstacle. And if I choose to go this way now, I cannot visit this path. So you got two paths. How would you write the same logic? So first, let's try coding this. Yeah. So I've previously written the boilerplate as well as taken the test case. The test case we have discussed previously, the same grid. So to start with, first thing I should know my start coordinates, right? I should know my start coordinates. So I would name them as x comma y. These are my start coordinates. And I would traverse the whole grid. Before that, I should declare an element. All right. After this, what should I do? I should maintain, okay, I've already maintained variables for start coordinates. And how can I say my whole grid is visited? How can I say that my whole grid is visited? After my whole grid is visited, I observe something that, yeah, I haven't visited this yet. My whole grid is completely filled with obstacles. It's completely filled with obstacles. How many, at the end of the day, at the end of the algorithm, one block would be left. So how many empty ones would be there at the end of the algorithm? At the end of the problem, we would be left with, if it's an m cross n grid and empty cell count is say, so one cell would be left, one plus number of empty cells. One plus number of empty cells would be the count of obstacles. One plus number of empty cells, right? This one plus number of empty cells. Previously they were empty. So if I maintain the count of empty cells, I can say that the algorithm would end when empty plus one cells are, when all the empty cells are basically obstacles. Can I say that? Yes. So let's write an algorithm for this. So I should maintain the count of empty cells, right? So initially the empty cells I have is 0. If I see the number 1 in my grid, that means it's a start cell. That means it's a start cell. If grid of, let me make a function. Let me quickly make a function. A start. This would return a boolean value. Or else it should take some value A, let's say. So this should return a boolean value. Return A equal to 1. Alright. So if my A is 1, it would return 2. Otherwise false. If any cell of mine is a start cell, then x equal to I and y equal to j. Alright. Otherwise, if it's not, if it's an empty one, okay, if it's an empty one, let's do empty plus plus. If it's an empty cell, grid of ij is an empty cell, then do empty plus plus. Alright. Then now you have the count of empty cells, which would help you figure out when did you find a valid path. And we need to write the BFS code now. We need to write the BFS code now. So let's take a variable answer. Let's take a variable answer, or let's take it as number of paths currently equal to 0. In the DFS function, I would increment the number of paths. So I would pass number of paths as an argument. So my BFS function would take my grid. Sorry, what am I typing? Yeah. So this will take my grid, and What else it can take? It can take my empty count, as well as it should take my start as well as end. It should take my grid, empty, start and end, sorry, start x comma y coordinates, and finally it should take my number of paths. And at the end I would return my number of paths. Let's quickly make a DFS function. Keep it as void DFS. Since we need to modify grid, let's pass it by reference, then int empty, and what else could we take? What were the arguments here? X and y, int x, int y, and finally number of paths. Fine. Now let's mark x comma y as visited. How would you mark it as visited? As discussed in the previous approach. Yeah. What was the previous approach? Here you can see that marking as visited would mean marking it as obstacle, right? So first let's mark this as visited. That means marking as obstacle. Grid of xy equal to obstacle means -1, right? Yeah. Before that, let's check. Let's check if it's out of bounds or not. So bool is out of bounds. So let's check if it's out of bounds. How can we check? We would take int I, int j, two variables. So if there are two ways it can go out of bounds, right? So let's take two ways. One way would be if I is less than 0, or else let's take a single expression. Wait, bool expression equal to I is less than 0 or I is greater than, let's pass int n2, also int m. If I is less than 0, I is greater than n, then it's for sure out of bounds. If j is less than 0 or j is greater than n, then also it's out of bounds. X comma y comma grid dot size grid of 0 dot size, or else if it's an obstacle also. So let's make another check. If it's an obstacle, all right. So when it's an obstacle as well, what you need to do, you need to return from here. You cannot do anything. So it's not ij, it's x comma y, right? Yeah. So this would be the pruning part. Now we need to write the successful case. Successful case, what would be the successful case? We have discussed this previously. If number of empty cells plus 1 is equal to is equal to what? I guess we need to maintain another variable for counting the number of obstacles. So yeah. So there are two ways of checking it actually. Either we can maintain another variable, that would be better. That would be the better way. So let's take another variable, count, and let's declare it here. Count obstacles. Let's keep the name as count obstacles. All right. If obstacles count, so we need to take this here also. Yeah. If these two are equal, in that case, we have found a solution. So we have found a path. So number of paths plus plus. And now let's write the DFS for this. And before, let me tell you, before this, we'll be backtracking. If a path doesn't actually work out, if a path doesn't actually work out, we'll cancel it. We'll start from beginning again. So let's write DFS. What were the arguments? Grid and empty, grid empty, and so better write them in a loop. Let's take directions. So you can go in four directions, right? So let's take four directions. One direction is up, upwards. So in upwards case, what would be the coordinates that should be added? In upwards case, x coordinate won't change. Y coordinate would be, you're moving to the previous row, right? You're moving to the previous row. So minus 1 0 and 1 0 0 1 and 0 minus 1 lastly. Okay, so these are the directions we can move in. So my new x would be equal to my previous x, like old x plus direction of 0, and my new y would be equal to my old y plus direction of 1. And I need to call the DFS for these coordinates now. So let's do that. DFS grid, and it takes empty, which won't change, and new x, new y, and number of paths, and lastly count obstacles. This would be incremented, right? Since you have created a new obstacle here, new obstacle, this would be, and in this step we have marked this as visited to. All right. Initial value of reference to non-cons must be and its value. Okay. So there's some error here. We'll look at it later. And after this, we need to backtrack. We'll set it back to 0. That means set as unvisited, like you haven't visited it. This step we are backtracking. So that's the most of the code. Now let's see what's this error. So instead of passing this as an argument, how about declaring this globally? That would be a better one, a better thing to do. So let's take int count obstacles. Actually, no, the previous one was only fine because we are also backtracking it, right? If we declare globally, it's not possible. So let's see where's the error. Just some random syntax error popped out. So coming back to this, we shouldn't have taken this pass by reference. That's it. Yeah, everything fine. Let's submit this. Let's try submitting. Solution starts from here. Before that, let's try running this. And it failed. There might be some minor errors in this one. So once again, let's check the code. Start is 1. Okay, this should be -1, right? Yeah. And we need to enclose this in parentheses. That would be better. This is greater than or equal to. This is also greater than or equal to. Finally, so uh, instead of doing this, let's take another variable, previous. Like we are assigning this forcefully as 0, but it may or may not be 0, right? Previous state, whatever the previous state is, we would assign it back. Before actually changing here in this step, it was grid of xy, right? We'll reassign this previous state. And what else can be done? Let's run once again and check. It's giving absolutely wrong path, 9. So once again, let's find some more bugs. I feel the logic is right. Somewhere we have missed a statement or something like that. So one more blunder we have done is the successful case. Even if the obstacle count matches the empty count, we need to check for this, right? And after this statement, after this statement, place a return statement. Yeah, successful case would be if all the cells are filled and have reached the goal cell. Okay, so let's make another. If this is the case, then we should increment the number of paths, and let's try running this once again. And yeah, it's passed. So after a few errors, probably we have found an optimal solution. So let's submit this. Yeah, so the solution is submitted successfully. Thank you, everyone.